Michelle. My pronouns are she, her, and I am a senior software engineer at Netflix. Today, I am excited to talk to you about Netflix Workstations. Since this is currently the middle of the night for me, please feel free to direct any questions to my Twitter or LinkedIn, and I'll be answering whenever I wake up. One question I will answer now is that I have no power to renew or greenlight your favorite show. If I did, there would be a show called Cake with Michelle, where I just eat cake and tell you how great it is. It would be really boring, but I would love it. But what I can do is help artists and creators make the Netflix originals we all love. My team, Production Infrastructure Engineering, or PI, is responsible for helping to make sure they can work every day, all day, and not worry about the infrastructure powering their workstations. Here's what you're going to learn about today. What technology did we use? What was the problem? Who are the users? How did we make Netflix Workstations? What did we learn? And what's next? Before I talk about the problem and why we did this, I wanted to give a quick teaser trailer of the technology we use. If you are unfamiliar with any of them, don't worry. I'll be defining as I go. If you are an expert, great, I'll have some questions for you. So at the top is Go, having a cup of Java, Salt for configuration, and Spinnaker for fleet management. Images are made with Packer. Teradici and NiceDCV are the remote display protocols. We use a lot of AWS services, but I wanted to highlight EC2 as the actual instances, DynamoDB for the data, and SQS to support our event-driven microservices architecture. I mentioned NiceDCV, which comes with the EC2 instances. Historically, artists had machines built for them at their desks, and only had access to the data and applications when they were in the office. This system allowed for fully on-prem solutions that stopped at the door. There are a few reasons why this is not feasible. First was the vast shift to work from home in 2020. We had already started the project in late 2019, but it accelerated our timeline. While people are beginning to come back to an office in some regions, the work landscape has irrevocably changed. The second reason, and our initial project mandate, is that Netflix wants to make content at an unprecedented scale. I've worked in entertainment technology almost my entire career and never on this many projects at once. There are simply not enough artists in a single geographic location to support the Netflix scale of content. Productions need to meet artists where they are instead of trying to bring everyone to one place. Finally, by taking down traditional geographic barriers to entry, the industry and Netflix becomes more accessible to all types of people. Losing access to great talent because they live 100 miles from the closest office or have mobility restrictions is simply not acceptable. The North Star for Netflix Workstations was to provide the infrastructure for artists to get a one-click experience to go from sitting down to working on a shot. But that can also be accomplished by building a computer and shipping it to them. Why not do that instead? The answer is flexibility and security. Production needs can change fast. New cameras and new software make it an ever-evolving space. By creating cloud-based workstations, adding anything from new features to security patches can be done quickly. A user can switch from one operating system to another by opening a new window instead of a new computer. Instead of waiting for a package in the mail, they can get a more powerful GPU or larger storage with a configuration change. Workstations, like many cloud-based applications, are not designed to be permanent. Artists are renting a workstation, not buying it. The downside to flexibility is accounting for other features that come with a single desktop, such as persistent user settings. When working on a desktop, user and software settings are just sitting on the hard drive wherever the software puts them. With cloud-based solutions, we had to be more methodical and save crucial settings to persistent storage, associate that with the user, and attach that storage to all future workstations. Asset security is critical. Inside studios, files have traditionally been passed around many different ways, from FTP to email to mailing a hard drive. Every time a file gets moved, it creates an access point for interception. By having all the assets on cloud storage along with the virtual workstation, files do not have to pass through intermediate services. It allows for granular control of a file's lifecycle and access since they never leave the original storage. When designing Netflix workstations, we had to balance the needs of three significant personas: artists, technical directors, and pipeline engineers, as well as the many supporting teams such as storage, networking, etc. Let's dig a little deeper into these users. Artists want to focus on their art and not on technology. They are the main end users of a workstation. They want to get to work immediately and not wait for a computer to boot up or to figure out what files they need to download. Artist workflows can vary wildly depending on the step of the production process they are on, but their basic needs are the same. Artists have source files that include anything from original film plates to reference images to LiDAR scans. The artist can then use digital content creation or DCC applications to create new images. They can be final drawings or the blueprint for a render. These new files then have to be shared for review. All of these steps would ideally be completed on a Netflix workstation, which include other tools and plugins to manage the pipeline, such as task management and shot review. Technical directors have both artistic and technical knowledge. They work daily to improve the artist's experience. They need to be able to create scripts and plugins for the artists and debug their problems. They also need to do the same tasks as an artist in order to troubleshoot any DCC issues. Technical directors decide on software and ensure the artists are on the correct configuration for their task. Pipeline engineers focus exclusively on creating pipelines or workflows. Their portfolio can include file orchestration, license management, or anything else needed for the artist to complete their work. They glue the pieces of the pipeline together with Netflix workstations in the middle. They make sure that artists can work as efficiently and smoothly as possible. My team started with a strong emphasis on building a complete white glove product for the artist to use. The plan was always to move to a more self-service model. The first step was adding features to allow technical directors to customize their experience. The next step is moving towards a platform for the pipeline engineers to build on top of to provide a curated artist experience. Starting a brand new project can involve making hundreds of technical decisions, both big and small. It can be overwhelming. Wondering if a choice made now will ruin an engineer's day a year from now. Well, I'm here to tell you not to worry too much about it because it definitely will. Have you ever worked on a legacy project and thought, wow, the engineer that wrote this was a genius and everything makes sense? Of course not. The engineers before you were always the worst because they worked with the constraints of what they knew then, not what you know now. So, now that I've completely demoralized you, I'm going to give you a little hope. There are techniques we use to reduce the bad choices future engineers have to live with. For all of my technical talks, I like to include an underlying theme of do less, accomplish more. That is, focus on solving the problem and only build what you absolutely have to. Netflix values at culture are freedom and responsibility, yet a commonly used design philosophy is that of the paved path. Tools and practices that are widely adopted and supported. Engineers can choose any tool or build any service, but it will be much easier if they can use the paved path. That matched my philosophy as well and guided many of the team's choices. Of course, sometimes you have to stretch a metaphor really far and pave a new path. You have to create or implement tools that haven't been used before. That's when I put a premium on solid community adoption, as well as reusability. If one service can solve multiple problems, it's more likely to get used for the long term. In order to explain the technology behind this large project, I've broken down Netflix workstations into the following main components. The first component is fleet management, which is making sure workstations are available and tracking their life cycle. The second component is configuration management, which makes sure the workstations can be designed for any artist's need, whether it is installing an application or editing an environment variable. The following two, package and image management, are both a subset of configuration management. Package management handles individual packages, like a single software installation, while image management handles collections of packages, such as specifying these packages are all required for compositing artists. Together, they ensure configurations are immutable with a clear history for stability and observability. The fifth component is user access, or role-based access control, and is how the right user gets the right workstation. Finally, remote display protocols are how the user connects to and interacts with the workstation remotely. Let's start with fleet management. Fleet management handles the life cycle of a given workstation, as well as pools of workstations with identical configurations. Pools are similar to an auto-scaling group in AWS, but the control plane controls the scaling. The control plane is a collection of Java Spring Boot services. Spring Boot allows for the easier creation of Java applications by abstracting away some of the common tasks. Java and Spring have a strong paid path here at Netflix, and many services use it. So the control plane tracks fleet needs and alerts Spinnaker to execute them. Spinnaker describes itself as an open-source, multi-cloud, continuous delivery platform that helps you release software changes with high velocity and confidence. It's a common tool for releasing and maintaining services at Netflix, and it's on the paid path. Spinnaker also controls the creation and destruction of workstation pools. Spinnaker uses pipelines as instructions for creating the pools of workstations, which it calls clusters. Pipelines can be accessed through an API and allow for variables and expressions. We set up a variety of variables that can be mixed and matched for each use case. For example, artists could need a GPU when doing graphics-intensive work, or extra large storage to handle file management. Some artists need CentOS 7 to handle their compositing software, while others require Windows to support their previous software. To minimize latency and get the workstations as close to the artist as possible, we support being able to select a growing list of regions and availability zones as well. The control plane directs the Spinnaker pipeline to run whenever it needs a new pool or more workstations. It connects to the Spinnaker clusters through the Spinnaker API to terminate a workstation once a user is done with it, or to remove whole pools once they have a stale configuration. The workstation has a Golang agent, which provides the heartbeat and other information about a workstation back to the control plane. The agent lets the control plane know the workstation is still up and in the correct state, or whether it needs attention. We chose Golang for the agent because it makes it easy to cross-build executables for different operating systems, which was an early requirement identified for the project. Configuration management starts with the control plane, but the details of software installation and configuration is handled by Salt. We needed a system that can manage hundreds to thousands of workstations while being highly flexible and easy for anyone to jump in and create new configurations. This is where Salt comes in. The control plane uses Salt to make operating system agnostic declarative statements about how to configure a workstation. It uses a combination of YAML, Jinja, and Python. It has many built-in modules, from installing a package to file management. It also allows for logic statements to handle situations such as mount the storage in this environment only, or only run the script if the file does not exist. This Salt formula example is the equivalent of running a yum install lighting 10.1 on a CentOS instance, or apt-get install lighting 10.1 on Ubuntu. The module is OS agnostic and should find the right installer per OS. Today, over 100 different packages have been written for workstations, from installing software to editing a registry. Salt was selected over other configuration management tools such as Ansible or Terraform because it was used recently in other Netflix projects and got high marks, as well as being Python-based. Python is a standard language for VFX and animation tools, so this was another opportunity to create bridges to pipeline engineers working directly on shows. Initially, we used Salt formulas directly, allowing for fast changes and quick deployment. Everything was always the latest, with no ability to lock to a specific version. Sounds great, right? As the project grew, the wild west of formulas became more challenging to manage. We created a package management system that wraps around the Salt formulas to enforce some rules. The first is a template for all formulas. This makes it easier to avoid naming conflicts and enforce rules such as this formula can be run only after the user information is available, or this formula is a PowerShell script, so should only be run on Windows. The second is that all packages are immutable. To use a package on a workstation, it needs to be published to a version. If any changes are made, it needs a new version. That makes it very clear what was wrong. It also allows for checks at the publishing stage, such as syntax and testing. If you're thinking that sounds kind of like Git, you're right. This structure made it easier for more of the technical directors and other engineers to contribute to the library of formulas and know exactly which code was run on an artist's workstation. The image management process has gone through multiple iterations as we learn more about the users and observed how they actually use the product. A workstation goes through 3 configuration stages: bake, run, and acquire. The different iterations will show how we move logic around to better serve the user's needs. The actual logic of each phase has been added to the chart and will be moving throughout the iteration. All of the deployed workstations start with an AMI. An AMI is an image used to launch a workstation in AWS. This bake stage is the process of turning a series of instructions into an immutable image. Spinnaker can then use that image to create a pool of workstations quickly. However, we found the process of baking can take a long time. We wanted to ensure that while we were in the alpha stage, we could quickly release new features. We didn't want to be held up by long waits while the AMI rebaked. So we only included minimal logic in the bake stage. This included just the operating system as well as installing internal tools such as the agent. Spinnaker creates the workstation during the run stage. Once the workstation is up, the Golang agent starts running and lets the control plane know it is available to be acquired. During the first iteration, there was no other configuration happening at the run stage. The acquire stage is when a user asks for a workstation. Most of the software installation, including all those DCC apps, and all the user configuration happen during the acquire stage, a just-in-time approach. Like making a sandwich once the order is placed, there was no pre-ordering before the user requested the workstation. This approach had maximum flexibility, but led to long wait times. As someone who will only get takeout at restaurants where I can order ahead, so it's ready when I get there, this was unacceptable. The long wait times led to us moving the software configuration and installation to the run stage. This created a pool of workstations that had specific configurations instead of just the basic operating system and internal tools. However, there are 2 risks with this method. The first risk was the making of many pools with slight variations. It turned out not to be an issue because, in practice, the usage patterns of the artists were not as diverse as initially thought. The same team tended to use the same configuration for extended periods. This meant that while there were many pools, the number did not grow to be unmanageable. Additionally, the teams tended to switch instead of using multiple configurations. The fleet management tools were instructed to terminate pools that had been idle for too long. Second risk is inefficiency. There were always idle workstations ready to go for artists, which meant they were sitting around lonely and unused. This was an intentional decision in favor of usability over efficiency. Of course, that means this is time for another iteration. The third and current, but probably not the last iteration, is pushing the software installation to the bake stage. This is like having a library of blueprints instead of a bunch of empty houses. Real estate is not wasted because, unlike houses, workstations can be built from baked images very quickly. But don't forget, we did not do this initially because of those long bake times. The process has now come full circle. Instead of abandoning baking, we improved the process and developed better tooling that allows for concurrent and easier bakes. The team also kept the other options as backup. One of the many lessons from bringing up a new project is hedge your bets. Technical directors who handle the configuration choices are encouraged to give some time between creating a new one and telling an artist he had a workstation so they're not waiting around for the bake. As with all projects, there are no perfect choices, just a bunch of trade-offs to maximize user experience, cost, and technical efficiency. The crucial part of any remote workstation experience is connecting to it. We currently use 2 different remote display protocols, NiceECV and Teradici. When deciding on which remote display protocol to use, The user must know how they want to connect. This is not decided by the artist, but rather by which workflow they are using. Generally, the pipeline engineers who originally got the artist team up and running decide on the workflow. Teradigi is a commercial solution consisting of a workstation agent, software or hardware client, and gateway components. NiceDCV is an AWS service provided on any EC2 instance and allows for a browser-based connection and application streaming. Application streaming allows for a streamlined experience so artists can jump right into their tasks without launching an entire desktop. For both of those protocols, latency and peripheral connectivity were vital features. For example, if an artist can't use their Wacom tablet or their 2 giant monitors, they will not be able to do their work as well on a remote workstation. Initially, all users acquired and accessed Netflix Workstation through a UI. Key components needed to allow for improved self-service are also in the UI. This includes giving technical directors the ability to create configurations and control access to them with role-based access control, or RBAC. The UI is also for operators to visually check on the health and usage of workstations, such as checking logs when a support request comes in or making sure an artist is using correct configuration. There are dashboards to check on common needs such as, are we out of licenses, or did the autoscaler go haywire and make 1,000 workstations with Among Us installed instead of compositing software again? That definitely did not happen. Over the past year, we realized that stakeholders were less interested in an opinionated product and more interested in a robust and customizable platform. Our current focus is shifting to API access instead of UI. Pipeline engineer partners will be relied upon to control how an artist experiences workstations. The core strengths of Netflix Workstations will be in common platform attributes such as reliability, observability, and customizations. By focusing on those and strong partnerships, Netflix Workstations can be leveraged for an even greater impact. To put it all together, our workstation starts with baking the AMI. This is where the majority of the configuration happens. Then Spinnaker handles the fleet management by turning the AMI into a workstation during the run stage. After that, the agent starts up and makes the workstation available for acquisition. Finally, once a user requests a workstation, they connect to it via the remote display provider. When they're all done with it, the workstation gets terminated and the cycle starts again. The system is designed for artists and everyone who supports them. Artists can get onboarded no matter their geographic location to accommodate dynamic production schedules. They can get any workstation they need with a configuration change instead of having to wait for a new one to arrive in the mail. Technical directors can quickly modify and control configurations to maintain stability while pushing out new tools. Pipeline engineers can build on top of the platform to customize the experience to a specific artist workflow. Everything was new when this project started. New roles, new teams, and an empty repository. We made the best choices with the information we had, then pivoted when real-world users showed us a different way. Here's some of what we learned about designing artist-driven technology. Nothing can be taken for granted when making a significant leap in technology. The new technology of cloud-based workstations must, at the very least, match the old experiences of dedicated on-prem workstations, or the user just won't use it. For example, users rely on their software settings to remain in place from one workday to the next, but that's not a given on a cloud-based workstation. Therefore, it's essential to learn all aspects of a user's workflow so nothing is missed. We focus first on technical flexibility instead of the artist experience. But artists need custom workflows, not standard solutions. By initially building the entire product, we were painted into a corner. We were on the hook for making everything, but unable to deliver that needed customization. Instead, we're pivoting to a platform to build a strong core and allow for partner customization. Empowering others to develop with you gives teams more leverage than they could accomplish as individuals. The more the system makes it easier for others to contribute, the better the adoption and iteration. Engineers need to help each other. Additionally, the artists require engineers to move fast, but not to break things. A seemingly impossible mandate, but one in which to aspire. It isn't fun when someone's first experience with a product isn't delightful. Observability and testing can seem like things that can be cut when timelines compress, but they quickly come back and haunt us. We have committed to improving this area, such as adding more robust automated testing, clearer failure modes, etc. And finally, address one thing at a time, from the micro to the macro level, from small tickets and small pull requests to small releases. If teams try to abstract too early and do everything at once, they'll never get it right. Doing one thing, validating it, and iterating is how to know a system is robust and on the right track. As part of that, here is my obligatory plug to come be a part of the team. If this got you excited about all the possibilities of building technology for a studio, please reach out. Thank you for listening, and thank you to my many stunning colleagues without whom there would be no Netflix workstations.